All right, so suppose that we have two arbitrary complex numbers given in polar form, and we want to see what their product is. Well, I mean, that's going to be R1, R2, and then it's going to be cis theta 1 times cis theta 2. R1 and R2 are simply non-negative real numbers, so I'm not worried about that product. But I am interested in what's going to happen with the cosines and sines. So when we multiply this, we'll get cosine theta 1, cosine theta 2, minus, because it's I squared, sine theta 1, sine theta 2, plus I, sine theta 1, cosine theta 2, plus cosine theta 1, sine theta 2. All right? And now if we look at that for a couple of minutes, it will occur to us that we've seen these formulas before, somewhere, a long, long time ago. And they are simply the sum formulas for cosine and sine. So what we see here is that multiplying two complex numbers is obtained by multiplying the modulus of the two complex numbers and adding their arguments. Okay? So we could say the modulus, and we already knew this, the modulus of Z1, Z2 is equal to the modulus of Z1 times the modulus of Z2, and the argument of Z1, Z2 is equal to the argument of Z1 plus the argument of Z2. Notice when I wrote those arguments, I did not use the principal value. And that's because this equation is not, in general, satisfied by the principal value. For example, you could obviously have two arguments that were both principal arguments whose sum was greater than pi. And that means that sum cannot be a principal argument. All right, but it will be related to that just by subtracting 2 pi. Okay? So what we get from this is that multiplication in the complex plane consists of a dilation and a rotation. To see that more clearly, let's look at a very simple example. Here is the complex number 4 plus 3i. If I multiply this complex number by I, I'll get 4i minus 3. So I could graph that like this. And if you think about it, you should be able to convince yourself that what's happened is we kept the modulus the same, because the modulus of I is 1, and multiplying by 1 is the same thing as not doing anything. All right? But we rotated the complex number counterclockwise about the origin through an angle of 90 degrees. The reason for that is that the argument of I is 90 degrees, pi over 2. So, and it doesn't just do that to the complex number 4 plus 3i. It does that to every complex number. It does that to the whole complex plane. Multiplication by I takes the whole complex plane and it rotates it counterclockwise through pi over 2 radians, or 90 degrees. Okay? Similarly, multiplying by 5i takes the whole plane and it stretches it out by a factor of 5, because the modulus of 5i is 5. So it stretches it out in a process that we call dilation, and then it rotates it counterclockwise. I keep doing counterclockwise like that, but that's counterclockwise to me. Counterclockwise to you is like that. Counterclockwise about the origin. Okay? And that's true of every complex number. All right? Multiplying by a complex number first dilates and then it rotates. It dilates by a factor of the modulus of the complex number you're multiplying by, and it rotates counterclockwise by the argument of the complex number you're multiplying by.